Next practice problem. Consider the following contingency table. So this is a similar problem, but by different numbers. Compute the following probabilities. Part A, probability of A given B. So please pause, work on this problem and find a solution, and then come back to see how it is solved. All right, let's see the solution. First, we need to complete this table here. So B is 10 plus 20, that's 30. We have 30 ways for B. We have 20 plus 40, which is 60 for B complement. That's going to add up a total of 90. So for A, for the row, it also should do the same. 10 plus 20 for A, that's 30. So A can happen by 30 ways. And A complement is 20 plus 40, which is 60. So here we have 30 plus 60, that's again 90. So the summation of columns should add up to the summation of rows. All right, so now we need to write the formula for the conditional probability. Probability of A condition on B, or given the B happen, is equal to probability of A and B divided by the probability of B. And this is equal to probability of A and B. A and B can happen 10 ways. So the probability of A and B is 10 out of 90. So this is 10 out of 90. Probability of B. B can happen 30 ways. So the probability of that would be 30 out of 90. 30 out of 90. So the probability of A given B would be 10 divided by 30. 10 divided by 30. Let me get rid of these. All right. Next problem. Probability of A given B complement. So let's write the formula for this. Probability of A given B complement, that's equal to the probability of A and B complement divided by the probability of B complement. So the probability of A and B complement can happen 20 ways. So that would be 20 out of the 90 total. 20 divided by 90. And for the probability of B complement can happen 60 ways. 60 out of 90 would be its probability. 60 out of 90. So to find the probability, that would be, we're going to get 90. That would be 20 divided by 60. So the probability of A given B complement is 20 out of 60. 20 out of 60. Let me get rid of these lines. All right, let's see the next question. Probability of A complement given B complement. So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So we're going to write the formula for this as well. Probability of A complement given B complement is equal to probability of A complement and B complement divided by the probability of B complement. A complement and B complement can happen 40 ways. out of 90. So that would be 40 divided by 90. Probability of B complement. B complement can happen 60 ways. So the probability would be 60 out of 90. 60 out of 90. We can get rid of these 90s, and the probability of A complement given B complement would be 40 divided by 60. 40 divided by 60. All right, let's see the next question. Are events A and B independent of each other? Event A and B independent. So if you remember, to answer this question, in the context of probability and statistics, independency of event A and B means that the condition probability of A given B is equal to A. That's the only way we can actually define the independency. You have to forget about any other definitions that you know about independency. So in the context of probability, we say A and B are independent if the probability of A given B is equal to the probability of A, meaning that knowing B has happened does not change the probability of A. So let's see if this is true. What is the probability of A given B? So we have computed here, that's 10 divided by 30. So that's 10 divided by 30. 10 divided by 30. You want to see whether this is true or not. What is the probability of A? Probability of A. Let's find the probability of A. To find the probability of A can happen 30 ways. So the probability of A would be 30 out of 90. 30 out of 90 is actually equal to 10 out of 30, right? So we actually can see that 10 out of 30 is equal to 10 out of 30. So these two are actually equal, meaning A and B are independent from each other. Next practice problem. So here I'm going to give you a demo of a deck of cards. Apparently some of you are not familiar with a deck of cards. So this is just a brief introduction. A deck of cards has four what is called as suits here. As you see, different shapes here. These are called suit. The first suit is called club. And as you see here, it has a shape like this. Something like that. Not great as drawing, especially with the stylus. The next suit is a spade. A spade, this is how a spade look like. The next suit is heart. As you see, you're familiar with heart. Next one is diamond. So this is a diamond. All right. Each suit has 13 cards. We have the one card, which is called the ace. This is ace. And then we have the 2 card, the 3 card, 4, 5, 6, up to 10. And after that, we have jack. This is jack. And then we have queen. And then we have the king. So we have a total of 4 suits multiplied by each suit had 13 cards. So we have a total of 52 cards. So a deck of cards has a total of 52 cards. All right, let me get rid of these. All right, suppose that I have a deck of well shuffled cards. They are all mixed up very well. Then I'm going to give you 2 cards one at a time. um, with no replacement. That means I'm going to give you the first card. You don't look at it. You're going to take another card. I'm going to give you another card. So this is called without replacement. And what we are interested in is the probability that both of the cards that you get are queens. So please pause, try to think about this problem to solve it, and after that, come back to see the solution. All right, so let's see the solution. So here, we're going to define the two events. A is the event that the first card is a queen, and B is the event that the second card is a queen. What we are interested in is the probability that A, the first card is a queen, and the second card is a queen. So we are looking for the probability of A and B. A and B. All right, let's see a table here. So this is the table. I'm going to write the formula down here. All right, the formula is down here so you can see the table. So probability of A and B. The first card should be a queen and the second card should be a queen. The first card to be queen. At the beginning, there are 4 queens out of 52 cards. So there is a probability of 4 out of 52 to have the first card to be a queen. The second card, when you pick the second card, if the first card is a queen, then you don't have four actually queens. You have 3 queens left when you draw when I give you the second card. And also there are 51 cards left. So the probability of getting the second card a queen, knowing that the first card was a queen because we want to have 2 queens, is 3 out of 51. 3 out of 51. So we want these two to happen, the first card to be a queen and the second card to be a queen. So that's a total of 4 out of 50, 4 out of 52 multiplied by 3 out of 50, which is equal to, which is about 0.0045. That's the probability of having 2 cards, queens, into sequence card giving away. All right. Let's see the next part of the problem. What is the probability that the first card is a 10 and the second card is a 5 or a 6? So please pause, work on the problem, try to solve it, and then come back to see the solution. All right, let's see the solution. So we're going to define 2 events here for the first card and second card. A is the event that the first card is a 10. B is the event that the second card is a 5 or 6. So what we are looking for the probability that the first card is a 10 and the second card is a 5 or a 6. So we are looking for the probability that A and B happens at the same time. This is a joint probability. All right, so for A and B to happen at the same time, A needs to happen, B needs to happen. So let's start with for A. How would A happens? That means the first card is a 10. We have a total of 4 10s, right, for each suit. So, and total of 52 cards. So the probability that at the first card you get a 10 is 4 out of 52. 4 out of 52. Now that the first card was a 10, the second card we want to be either a 5 or a 6. So here we have or, right? So how we can compute this? We need to find the probability of B happening, knowing that A has happened. What's that probability? So when the first card has been a 10, we have 4 5, 4 6s, and 51 cards. So we have a total of 51 cards. And we want to pick either a 5 or a 6. We have four 5s and 4 6s. So we have a total of possibility of 8 cards that we can have a 5 or a 6. And if you multiply these together, we're going to get the answer. All right, so this is 8, which is equal to, which approximately is equal to 12 thousandths, 0.12, 0.012. All right, let's see the next part of the question, part C. If you were sampling from with replacement, the first card is returned to the deck of cards after you selected it. What would be the answer in part A? Part A asks for what is the probability that both cards are queens. So this question asks for if I have full deck of cards, 52 cards, and I give you one card, you take a look at it, then you give it back, and the second time I'm going to give you a card while I have the 52 cards. What is the probability that the first time and second time you have, the both of time you have queens? So please think about this question and solve the question, and then after that come back to see the solution. All right, let's see the solution. So we're gonna define two events. A is the event that the first card is a queen, and B is the event that the second card is a queen. So what we are looking for is the probability that A and B happens. The first time you get a queen, the second time also you get a queen. All right, what is the probability that you first time you get a queen? So the first time when I give you a card, I have 52 cards, 4 of them are queens. So the probability that I give you a queen is 4 out of 52. Then I put the card back. So the next time I have also 52 cards. So the probability that the second card, the second time you also get a queen is 4 out of 52, which is equal to about 59,000. So 0.0059. How is this different from the previous question that we had? Let me get rid of this. So previously in part A, there was no replacement. I didn't put the first card back. So I gave you one card. You take a look at, you didn't take a look at it. I gave you another card. So I gave you 2 cards in a row. And the probability of that was different. So let's see how that would work with replacement and without replacement. So the probability of 2 queens without replacement, the part A that we had previously, it would be 4 out of 52 the first time, the first card. Then when I give you one queen, I have 3 queens left and 51 cards left. So it would be 3 out of 51, which is the probability is about 0.0045. With replacement, if I put the first card back, then the probability for the first card is 4 out of 52. The second term is also 4 out of 52, which is a total of 0.0059. As you see here, this value is bigger than this value. So the probability with replacement is higher. All right.